Okay, so welcome to the beginning of the second day for EPIQ. A few things of note. There's one thing that we forgot to mention last night that we probably should have. And that is that part of, as Linda McIver mentioned in her keynote, part of doing data science is trying to find something that has interesting local context or interesting motivation for people. And so one of the things that we had put in the schedule but forgot to mention was that we put in 4 assignments for people to do as they were going through EPIQ this particular year. Now, obviously, we're not going to be grading these assignments and stuff like that, but the idea is that we want people to be able to do some kind of an activity that will give them something that's interesting to them. And so last night's assignment, which was for, to think about over the next few days, is to find something you want to collect data about or find data sources to use for analysis. So here's the idea. By the end of the week, there's going to be a teacher session, which is a teacher showcase, where we're going to have people demonstrate something that they either collected data about or data that they gathered about, something in their local area that they're interested in, that they were able to get some data on. Whatever it is that's interesting to you is just fine, but we want people to use the data science and analysis tools to demonstrate some kind of evidence about that thing that you care about in your local context. So what that means is, for last night, it was finding a data source, which we forgot to mention. And then today is load, filter, and clean data sets and gather descriptive statistics on it. And those were actually changed around a little because some of that stuff is going to come tomorrow. But the point is to start experimenting with the actual data, finding this data and playing with it so that you can start to feel comfortable loading it into Quorum and doing some data science operations on it. So that's the idea. Besides that, we have a series of lessons today, and they are on, first is like an intro to programming. Some people will already know that stuff, and that's okay. And then we're going to get into the data science context. The first is loading data frames. Data frames are kind of like a spreadsheet, but inside of memory in the computer. Then we're going to start talking about charts, and this is going to include the accessibility stuff and how it works. For Derek, since I know that you're on the call and you're in the research team, not to single you out, note that all the keyboard stuff has changed pretty dramatically in the last week. So because we've been experimenting a lot internally. So when we get to the screen reader stuff, it'll be a different planet. So just FYI that's changed. So and then once we finish sort of the overview of the different charts and types and stuff like that, then we're going to move to building our own bar charts. Probably in a couple of different contexts, online, offline, and look at the implications of all that. So before we get going, is there any comments, questions, concerns, things we're missing, things they want us to do, anything like that? All right. So Amanda, Rodda, then I leave it to you and go ahead and take it away.
Excellent. Good morning, everybody. Do we all have our coffee or beverage of choice to wake us up? Remember, I am West Coast, so I am still waking up. All right. The lesson that I'm going to kind of walk through is on the schedule spreadsheet, Introduction to Programming. We're starting very, very basic here. Okay, so if you already know it, just, play along. It'll be great. First, let's all open Quorum Studio. Make sure we get that actually working for everybody this morning. I say that as I also have to do it. Oh. Uh-oh.
May I take this moment to thank you for demonstrating what happens to me whenever I do things in front of people. Thank you so much, Amanda.
Is it not pulling up for some reason? I don't actually see the screen share. Does anybody else see it?
I do not.
No.
I actually, I can't
think
even
she's
tell
frozen.
if, yeah, I think Amanda's frozen.
Oh,
Or she is doing a really good job of holding that concerned expression really still, letting us soak it
Without
in.
cursing.
and
There she
there
goes.
goes. All right. Let's see here. I'm going to share screen then.
See, you don't get this when we have live epics. You don't have people just sort of like phase out of the room suddenly and say, ah, dang it, Amanda just disappeared. Now someone else has to go. And
It actually did happen once in Wisconsin because I got food poisoning and literally just walked out and Amanda took over because, you know, that. Okay, if
fair
she
enough.
can pull back up, I'm just going to share screen and I'll jump in. Okay, so here's the deal with programming as I pull up the lesson. Oh, types it up, but okay. Oftentimes in programming, one of the things that's really difficult here is that programming is like a million different things. It's not like I'm learning about conditionals, I'm learning about how to write a loop. It is those things, but it's a lot of other things too. And part of the challenge and kind of difficulty in programming is that a lot of it kind of builds on itself. And oh, I don't know what you're holding up, Tim, but oh yeah, a cheat sheet, the cheat sheet, yeah. And so one of the things that's a little bit tricky is that every programming language has what is called a type system. And in this tutorial, we're going to kind of talk about this concept of type systems and what it means in the context of programming. So what I want everybody to do is I want you to either go to the menu, which you can press Alt to get to, and then go down to New Project, which is New Project. You can also press the hotkey, which is Command N. And you can also press the mnemonic if you prefer, which is Alt F, which will get you to the menu. And then you can press Enter. Of course, you can use the mouse as well, but I always try to say the hotkeys because, especially for screen reader users, you know, they're very helpful. Once you've got there, the new project window has a series of options, and we mentioned them yesterday, but I'm just going to reiterate really quick so that everybody kind of has a sense. There's some general options. These are like blank projects. Blank and main are just generic projects that do nothing intentionally. There's a series of graphics projects for different kinds of games that you can generate by default. 2D physics, skyboxes, image sheets. You may not know what all those little details are, but the point is they're different kinds of graphics projects. Like a skybox lets you see 3D terrain in a funny, funky way. There are scenes. This is if you're making 2D or 3D games. It's an easier way to make those games. That works also accessibly. Lego Mindstorm stuff, and then a bunch of kind of random projects related to Android and stuff like that. We're going to make a blank project, and we're going to give it a name that's going to be something like Type Systems Study. Okay. And I put that in the name field, and then I can either press Enter to go to the OK button, or I can, Tab, or I can press Enter, and that will just finish it off. Before I keep going, can everyone tell me that they've gotten to this point, just so that I know that we're all on the same page? And if not, that's okay. I can wait a minute. See, one thumbs up. No, wait a minute. There's no hurry. Oh, and Amanda Rodda came back too.
Hey, I'm alive.
No problem.
Except-
Well, I took over, and I'll hand it back to you, but I'll tell you where we're at.
Well, now my Quorum won't open.
Oh, okay. Well then, jump into the room with Gabriel, get that settled for now, and I'll keep going while we do that. Nope, no
That'd be
problem.
great.
Not a problem. It's okay. Okay. So once we have a project that we've made, there's a couple things inside of it. There's a little bunny, and the bunny doesn't actually output that it's a bunny in a screen reader, but it doesn't really matter. It's just art. And I've got, it says type system study. This is the name of my project. There's a little thing, and in dark mode, it's orange, and it says source code. This is where all my source code lives. And then there's a file that says main.quorum, and main.quorum is just a text file. There's nothing special about it whatsoever. It's just a text file. If I press enter on that, if I press enter on that, then what happens is it brings me into a normal text editor, and I can start to write code that does whatever I want. But of course, the problem is, what kind of code do I write? Because like, you're literally looking at a blank screen and you're asking yourself, well, what on earth do I even do? And so this is actually a tricky thing. This is actually a tricky thing. Oh, not sure what that was. This is a tricky thing in computer science. What do I even do? And so oftentimes it gets easier to answer this question once you've had practice writing different kinds of specific applications. For example, at this point in my career, I've programmed for so long that I don't really have to think about, how to get from point A to point B in terms of programming. But the problem is that's that assumes that I know what I'm trying to invent, which isn't always the case. Because in other words, you kind of need some foundational stuff to figure out where to get to so that you can start to even ask questions about what things you should invent and when. And one of the most foundational aspects of that is a programming language's type system. And a type is a made up thing that has a property. Okay, and I'm going to write an example on the screen, and it's going to say integer, and then I'm going to say name equals 5. Okay, and then I'm going to explain this line of code as we go. Integer, if someone can tell me what is an integer in math? It's exactly the same here.
A number.
It's a number with what properties?
No decimals.
No decimals. And in computer science, it's exactly the same with one exception. With one exception. Does anybody know what that is? There's one difference between a normal integer and a computer integer. It's not obvious, but I'll give you a hint. Do computers have unlimited amounts of memory? I see Mike shaking his head no, and Derek. So here's the problem. The problem is in the computer, computers don't. They don't have unlimited amounts of memory. If they did, that would be very handy. But they don't. So what happens is in the computer, we actually set rules about how big the numbers are. And in a typical computer, we measure this in bits or bytes. Bits is the number of ones and zeros. So, and integers traditionally are 32 of them. Why? It doesn't really matter. The truth is that like different programming languages have different rules. There's some complexity there. But traditionally, integers are 32 bits. And that's true in Quorum as well. There are 64-bit integers. There are smaller ones. But when you think of the 32 bits, you think about this in the number of how big it can get. So a 32-bit integer, what is the maximum size number that can store? Can anybody figure out how you calculate that? What would you think it would be if you've got 32 ones and zeros? I'll give you a hint. It's a little bit weird. If I had a zero, just a zero in my 32 bits, technically there's 32 ones and zeros. I'm not going to count them out, but on my screen, there's a whole bunch of zeros. If it's all zeros, we would expect that number is 0, right? What if it's all zeros and then a 1? What number would that be? 1 is what I see someone holding up their finger. What if we had all zeros, but then a 1 and a 0?
10.
Yeah, you would think it'd be 10, right? But here's the tricky part. In computer science, everything is base 2. Base 2, if we can remember our old ridiculous math nonsense. And actually, there's a lot of tradition around why this is, but it's not just tradition. It has to do with the fact that transistors, the actual physical components, are slightly easier to build when there's only two states, on or off. It is actually possible to make a computer where you have multiple states, but it's just, they generally don't do that. So if you had all zeros, then that means you've actually got 0, 2 to the zeros. And if you've got 1 0, then that means you've got 2 to the 1, 1 times 2 to the 1 plus 2 to the 0. Okay. And similarly, if I had 1 1 0, that would be 2 to the 2 plus 2 to the 1 plus 2 to the 0. Okay, so this is getting a little bit complicated, but 2 to the 2 is 4 plus 2 is 6, and that means that number 110 is 6. Okay, so conceptually, you don't need to memorize the binary for these things. Most programmers don't. It's not really necessary, and there's some complicated rules about it anyway. But the point is, what you want to understand is that integers have limited size. They can't go forever. And you give them a name, and then you give them a value. You give them a name and a value. And if you know that much, then you can do an integer. So what I want everybody to do is make an integer, give it a value, and then we're going to output it to the computer and run our program. So to do that, I say output name. Okay, so I got in my first line of code, integer name equals 5, which says make an integer, that's the type. It has the name, which I can reference later in my program. And then the value is 5. Yes, but it's 0 times 2 to the 0. Yeah, 0 times, that's the 1 or the 0. Yeah, you caught me for a second too. You're right. That's exactly right. And I think I had it wrong in my video. So thank you for clarifying. You're absolutely right. Okay. So to run this program, there's a couple ways to do it. And I'll remind you, I can either press the mnemonic of Alt-R, which gets me to the menu, and I can navigate down to the run command, which is shown on the screen right now. Run is Alt-R, then press down arrow 4 times to get to run. I can do that. Or I can press the hotkey, which is shown in the mnemonic, which is Command-R. And that's what I actually recommend doing, because it gets pretty natural to just be able to click a key. It's quite handy. We don't have to. You can also click the little run button with the mouse too. You can also navigate to the toolbar and do it that way, but that seems kind of like pointless. So I can either press the run button, I can go to the menu, or I can memorize the hotkey, which is Command-R on Mac and Control-R on Windows. So if I run that, on the very bottom of my screen, which I can get to with the keyboard if I'm using a screen reader by Apple 3, or I think it's Control 3 on Windows. And it says building type system study, running type system study, and then build successful in 0.08 seconds, and then 5. So line by line, it's saying that it's building it, which basically means it's putting some stuff on your hard drive that is the actual computer program that you've created. And then it's running it, and then you get the output 5. Tiffany, I see a question.
Yesterday when we were practicing, the stuff was coming up at the bottom of my screen, but today I just see the place where I input the stuff, but I don't see the information underneath, errors, variables, like the stuff that comes up down there. I don't see it today.
Oh, weird. Without seeing your screen, I can't know for sure. William or Tim Cluthy, do you mind jumping into a breakout with Tiffany real quick and trying to get that resolved?
Yeah, I can go in a breakout.
Is that okay with you, Tiffany? Then we can make sure.
Yes, definitely.
Okay, great. Let me, excuse me. I'll put you in breakout 2, Tim. In theory, there we go. 1 second. Just assigning it now. And Tiffany. Okay, you should both be assigned. You should be able to go. Okay, now integers are all well and good. We can write quite a lot of programs with just integers, but there's different types as well. And there's really 4 basic common ones. There's integers, there's numbers, and a number is very similar to an integer, except it has a decimal point. And so to make a number, it's number mynum or some name of that you want equals 5.0 or 1.0 or 0.0. Now we won't get into the binary of these kind of numbers because it's a little bit complicated. There's actually an international specification about it that's kind of gross. And it's complicated because of lots of reasons, like how do you, that there's not a number net values put in there. There's also some little complexity related to that. But these kind of numbers, at least in Quorum, are actually 64-bit. They're much, much larger than the 32-bit integers, and they have to handle decimal points with exponents in there as well. So the interesting thing about numbers is that you can make ones that are much, much bigger than you could otherwise. So if I want to output one of these, I might say output my num, and now it should run 2 things on the bottom, 5 and 5.0. Okay. Besides integers and numbers, there's also 2 more. One of them is Boolean. What's a Boolean?
True or false?
True or false? Yep. So in this case, I'll name my Boolean Boo, because maybe it's Halloween. And I can set that equal to only 2 values, either true or false. You can also use other expressions like or, like true, false, or false, which would be false. So you can use logical expressions in there too. And you can output those as well. If I output boo, then it just outputs the word true to the console. And there's one final type, and that is text. And text is probably the trickiest of them. And I'm gonna name mine hello. And if I set that equal to something, I have to encase it within double quotes. Sorry, 1 second. So if I say text hello, it's equal to double quote, and then I can put in any value that I want. And then that's it. So 2 double quotes and it's encased within it. And perhaps it's below there. Now, of course, the one tricky thing is there is a little bit of complexity in strings because there's all sorts of special characters in text processing. And I'm not going to get into all the nuances because it can get a little complicated, but you can imagine, what if I want to double quote in my text value? Well, that gets a little tricky. And then what if I want a new line character, like a carriage return in my thing? What if I want characters in Chinese or Japanese or stuff like that? You can do all that, but it can get a little bit hairy for how you manage it, and the complexity level can go a little above. But this is kind of common parlance for programming. You can, there's a lot of stuff that you can do with a little bit of training, and that sometimes in order to accomplish some complicated program, it takes kind of a deep dive, even for people with considerable expertise. It can often take some real study to figure out how to write certain kinds of software. Like in our lab, we've been writing accessibility software for a long time, but we learn a lot of new stuff all the time because it turns out to be pretty complicated. So, okay, now I can then output my string as well, my text, output hello. And there we go. 5.0, true, and hello there. Okay, before I go on, are there any questions, comments, or concerns? Okay. All right, so that's types. Type systems as a concept are much more complicated, but this is the basics, and this is the stuff that you kind of need to know to get started. Besides constants, there's also a tutorial, and we'll talk about it really quick on operators, and I'm going to put that into the Slack channel under the EPIQ branch. And I'm going to briefly switch to the online tutorial. And the reason I'm going to do this is not because doing it online is better than doing it through Quorum Studio. I just want to show that you can do this stuff online too. So like if you're in a school district and you have challenges with getting stuff installed because of administrative staff or whatever reason, or state rules and stuff like that, you can also run this stuff online and it works just fine. Now, I will tell you that different kinds of computers do have still complex accessibility needs. So for example, Chromebooks are kind of tricky in terms of accessibility. So although we are following all the standards that you would want to use for accessibility, just be aware that things aren't perfect depending upon the kind of machine that you're running on. So, okay, so let's pull up this tutorial that I have there, and we're going to look at the various operations. And I'm not going to do each one of them, but I just kind of want to highlight what they are. So most programming languages have the concept of addition, and addition means different things for different types. Okay, I want to say that again because it is a little bit confusing. Addition means different things for different types. Okay. Now, the reason for this is because types imply how the computer is representing it. So, for example, an integer, I showed you kind of a binary format, and the computer has a way of adding when it's in that binary format. But if you have floating point values or numbers, as they're called, the computer has to add it a different way. So there's different operations. And even still, if you have a text value, so fire plus fox, you're not adding in the same way that you would be if you're adding integers, because it just doesn't mean the same thing to the computer. So let's, as an example, let's make a text value and let's add two text values together. So in my particular case, I'm going to say text value is equal to, and I'm going to mimic the example. I'm going to say, no, I'm not. I'm going to make an Obi-Wan Kenobi joke. I'm going to say hello space plus there. And each piece has to have double quotes around it. So hello has double quotes around it. And then there has double quotes around it as well. And then when I output this, what do people think that it should output to the screen? What should his output? If I say hello plus there.
I know.
What?
Oh, I don't know if you put spaces anywhere. I
I
can't
did.
see.
Sorry, I should have
Oh.
said that. Hello space plus there.
Then it's going to output hello there with a space between the words.
Yeah, exactly.
It's more fun if you don't put spaces in.
Okay, I'll do that then. Okay, now, if I do this, then I can either click the run button, or I can press tab to go to the run button and then select it. Or I can press the hotkey. Although I will say, we were looking at this recently and we realized, and this is our own dumb mistake, that the hotkey is Control+R, but in some browsers use Control+R to refresh the page. So we're going to change that key for those browsers. That's our fault. We will fix that. in any case, though, if I press on my machine, at least Control+R, it does output hello there. And if you're using a screen reader, it sends that through what's called an ARIA live region, which what that means is that that'll trigger your screen reader to say something as you go. Okay. Now there's no game here, so there's no like graphics window that pops up or anything like that, but it will output the text as you go. Now, the last thing that I will at least mention, if you run this program multiple times, you actually won't be taxing our server very much. So you can feel free to use this online system as much as you want because our server's relatively smart about, caching the kinds of things that it sees and stuff like that. So you can kind of feel free to use the online system as much as you see fit. Oh, Amanda's back.
Oh, but I'm hopping back out.
Oh, okay. That's all right.
I'm sorry. My quorum decided to,
Have a heart attack.
uh-huh.
Okay.
We'll use that phrase.
Okay, so now let's take a look at the minus. And the reason it's kind of interesting to look at minus is because you might think that, addition is just like subtraction, so it's going to be the same thing. So let's actually try the same thing, our hello there text value, but instead of plus, let's just make it minus. Oops, hello minus there. And we're going to output value. Now, if we do this, so the text, oh, you know what? I should put that in Slack so everybody has it. I've been just verbally saying it, but I shouldn't do that. Yeah, so sorry, I mean to do that. Like anytime that I have an example, I'll try to dump it in Slack so you can straight up copy. You don't have to memorize what I'm saying for sure. So, so without running it, what do we all think this code would do? Hello minus there. What do you think? If no one knows, it's okay to just take a guess.
Take something away.
Yeah, maybe take something away. What would it be? Like maybe like it looks for the word there inside of hello or something like that. The truth of the matter is sometimes in programming, it's not obvious what the operators should do. And so sometimes as computer scientists, we've made kind of judgment calls that may be wrong, right? In the case of the minus operator, hello minus there, the decision, at least in the case of Quorum and in most programming languages actually, is that hello minus there is an error, okay? And when I say error, what it means is that the computer is going to tell us that it can't do that operation. So if I press Control B, in the text editor, it's going to come out with a message that says, I did not understand. Line 1, column 13, the operation text minus text is not allowed. And its error messages are kind of a dark art, and our Quorum's error messages have gotten much better over the last few years, largely because of work that happened overseas, evidence from scholars in New Zealand and in Ireland, named Brett Becker and Paul Denny especially. They've shown quite a bit of evidence on how to structure the errors, what they should say, and stuff like that. And so Quorum's messages have gotten much, much better in the last few years through no fault of our own. But nonetheless, even then, writing messages that are meaningful to people is a very complicated and hard problem for the obvious reason that you're turning technical stuff into something for humans, right? That a layperson can understand. But the moral of the story is subtraction is what it is for numbers. But when you have text or other types of values, subtraction may not be allowed. And the computer will tell you what's allowed and what isn't as you try to build out programs. Okay, now the same is true for the times operator and the divide operator, but I'll skip past times because the meaning is relatively clear, just like in middle school, but divide is less so. So if we do a division, I'm going to make an integer top, I'm going to make it 10, and I'm going to make an integer bottom equals 3, and then I'm going to output top divided by bottom. Okay, I'm going to put this in Slack. And when I run this particular code, and I'm just going to run it. I didn't hear what you said, Derek, if you meant, oh, okay. In this particular case, the computer, because they're integers, is going to do something very specific, right? When I run this code, it's actually going to say, excuse me, that the answer is 3, okay? And it does this for good reason. And that's because oftentimes when you're using whole numbers in the computer, you're using it as kind of like, well, often a way to control flow and stuff like that. And so you're thinking about it, I only want the number of whole parts inside of something. So in this particular case, it ignores the remainder of a division. And that's very common in programming. But you'll notice if I change this to numbers, number top, number bottom, and I run the same code, it says 3.33333333333, etc. And that's because when you have numbers, the computer makes the assumption that you're not looking for whole pieces. The computer makes the assumption that you're wanting the actual value, which in a way sounds a little bit odd, but it also kind of makes sense because you can't return an integer with a partial value. So the best you could do is give the amount and the remainder. So you have to choose something in that particular context. So let's go back to integers really. So if I had integer top equals 10, integer bottom equals 3, and then output top divided by bottom, that gives me 3. And if I want the remainder, then I actually say mod. And that will return 1. Interestingly, studies on what word to use there are a little bit unclear. Mod does well in surveys. Words like remainder also do well, but they're longer, et cetera, et cetera. Modulus is the technical term.
Where do you put mod?
Sorry, I'll put that in Slack. So it's output top, mod bottom.
Instead of the division symbol.
Correct. In some programming languages, they represent this as the % sign. Why? I don't really know. Historically, somebody chose that, and then that's been used on a number of programming languages. On Quorum, we tend to do studies to try to survey people and do other kinds of things to try to figure out what word or symbol should be in there. And mod just happens to be the one that pops out in the studies. So I don't think it's personally perfect either because it's a shortened version of the word modulus. And it feels to me like words like remainder are more clear, but statistically, that doesn't seem to pull out in the data. So we tend to kind of go with just whatever we find instead. So. Okay, so that's divide. Strings or text values don't have a modulus or a division operator associated with them. Because what would it mean, right? Like, what would it mean to divide a text by text? I don't really know. You could imagine that you could come up with such an operation, but generally speaking, it's not as clear. Okay, now, excuse me. Besides these operators, there's also conditional operators. So these are things like less than. And so on the screen now, I'm showing a Boolean operator. So if I say Boolean A, just the name, is equal to 5 is less than 6, and then output A, which I'll put in the Slack again. Then what I've got is a Boolean is a true or false. Those are the only 2 values that the computer will allow it to have. The name is A. I'm setting it equal to, which is what the equal sign means. And then 5 is less than 6. That happens to be true. And as such, Boolean output A should return true and output that, which it does. Cool. I mean, most of us understand conditional operators. There isn't really much to know besides that, but I just want to point out that you can use them. That's kind of the idea. You can do them with, you know, integers, numbers, and stuff like that. The only one that I think is a little bit tricky is actually the actual equals signs. And the reason I say that this one is mildly tricky is because in traditional computer science, they actually use a funny symbol for this. And so I'm going to actually write Boolean value is equal to, and then in traditional computer science, we actually use, and we don't do this in Quorum, but I'm just pointing it out so that you're aware. We use the double equal sign, and then we can say 5 double equals 5. But in fact, what actually happened historically is that different programming language designers made all sorts of weird rules about what symbol you use. Some programming languages like JavaScript actually use a triple equals sign in certain contexts. Some programming languages use a tilde equals sign in some contexts. And like, I don't remember off the top of my head what all of these mean, but in Quorum, we use a single equal sign, which is the same as assignment. We have done studies on this, and they show pretty clear, I mean, like borderline unequivocally, that this is easier for people to understand, with one exception. If you've got Boolean value equals 5, that's a little wonky because you're assigning something to value, and then on the right-hand side, the 5 = 5, that's saying compare to see if those are true. So if I say Boolean value equals 5, that will actually just give me the result of true, which is a little weird. I'm going to put that into the stuff again. So I'm going to point that one out. And if you want it to be not equals, you actually just say the word not before equals. In many areas of traditional science, it would actually be an exclamation point before the equals in some programming languages. It's not always uniform. I wish it was, but it's not. So. Okay. So that's really the big picture about operators. You also have and or, and those follow the rules that you might expect. Any questions, comments, or concerns on that? Okay, I'm not hearing any gnashing of teeth. That doesn't seem bad. Okay, so there's one last thing that I want to point out. We talked about it last night, but we're going to definitely go back to Quorum Studio for this one because it's way easier in Quorum Studio than it is in the web interface. There's a final thing in this tutorial called libraries, and we're going to need these a lot for this year's EPIQ. And the reason for this is because we're going to be touching the data science tools. And so generally when you're building programming languages, you don't build every possible combination of library into the main system. And the reason you don't do that is because you would melt your computer because it only has so much processing power. So you can't just do everything at once. You have to kind of pick and choose. So what we're going to do is we're going to be connecting into a very special library called the data frame. Data frame is debatably not a very good name. I honestly don't like the name very much. I think we should do some studies to change it. But nonetheless, a data frame is like a spreadsheet or a table or something like that. And so what we're going to do, go back to Quorum Studio, and I want you to type data frame with a capital D and a capital F. And I want you to say data frame and then give it a name. I'm just going to name mine frame. And you'll notice when this happens that there's visually a red underline under the frame. That means there's an error. And if I press Apple B, it says I could not locate a type named data frame. Did you forget a use statement? And what that's actually telling you is that that's a giant chunk, Derek. What that's telling you is that you're trying to use something in the computer and it doesn't know what that is because it's not all bundled in together on purpose because you'd go nuts, trust me. But the thing is that Quorum can often figure out what you probably mean because there's only one data frame in the entire system that's built in. So what we can do is we can either right click on the system and add a use automatically, or there's hotkeys for it as well. So if I right click on frame, it pulls up this little phrase that says, add use for libraries.compute.statistics.data frame. If you don't want to right click, you can press the context menu key, or you can press Alt Enter, which I press religiously as I do it. So memorizing Alt Enter is not a bad key to memorize. And then ta-da, it pulls up the code for using the data frame. Okay, so what this is saying, I want to load a library that Quorum has available. Now, you might ask yourself, well, what else can I load? The answer is, oh God, a lot. If you want to go crazy, let me show you the libraries page. And I warn you, this is not intended pedagogically. This is an auto-generated page of the list. Okay, for Quorum 10.0, if you'd like to go to it, you can. I'll just, oh, you know what? I'm gonna put it up here, share screen really quick, just so that people can kind of see the pain that would cause them if they looked at this. You can scroll, there's a page. The reason this page exists is so that you can Control F on it and try to find stuff if you need it and get more documentation. But trust me, the sheer number of classes and details that are here is out of this world. All sorts of stuff for graphics, all sorts of stuff for databases, web programming, and all sorts of things. These are not tutorials. They're not intended as tutorials. It's just like documentation about the kinds of things that are available on the system at any given time. But if I had a use statement, I could technically load any of these things if I knew what I was doing. I mean, there's probably 50 classes for just the text box alone, you know.
If you knew what you were doing, which you don't.
Well, and also too, you don't need to, right? Most of these things are hidden for good reason, right? It's kind of like, even if you're an expert mechanic and you're working on your car, you might be flipping out the carburetor if you have one of those old gas guzzlers. But like, you don't need to know exactly how a carburetor works. You might need to know that it exists, and you might be able to know that it needs to be replaced. But you don't necessarily need to know like all the mechanical engineering that goes into how it works. And that's true here too. Oftentimes there's some complex computer science that goes into building these libraries, but it's not really useful to know it because it's just too detailed. And this is the last point that I want to make about libraries before we take a few-minute break or ask questions. With libraries, a common mistake that I see amongst people that are learning to code is that they assume that they need to know how everything works. And here's the problem. You can't. It is literally impossible to know how every single library works. I mean, like, think about it like this. I invented Quorum. I know the language pretty well. I do not even remotely know how all of these libraries work. Not even close. I know. Derek has the shocked Pikachu face. But like, that's the truth. The reality is that like, as computer scientists or mathematicians, there's often areas of tools or languages that we know better than others. And oftentimes we work as a team because we have to, like, it's just the only way to make progress. So when your students are learning, they also need to know that they don't need to know everything about it. They just have to be able to make substantive progress, and they can use each other as help and you as help as well. That's kind of part of the game with this stuff. Okay, so we covered 3 things. We covered, oops, let me go back to it. Okay, I can't go back to it, fine. Be that way. We covered types and output, things like integers, numbers, text, and Boolean. We talked about operators and how they vary a little bit depending upon what kind of type it is. And then we also talked about libraries and how not only can we don't need to understand them all, but we learned that we can actually tell Quorum to figure out what library we need for us if we know the name, which we don't always. But if we know the name, and the tutorials will walk you through those names, if we know the name, then we can start to have it auto-generate some code for us. Now, one last thing I'll mention, as we get blocks, which we're adding next year to Quorum, as people know, or at least that's our first prototype, this will get a lot easier because blocks, the one thing that the research literature shows very clearly is that it makes it easier to explore what is available in programming. It's kind of like having an auto-generated cheat sheet at all times. It's very handy in that way. That's what David Weintraub's research shows, which I think it makes a lot of sense. Of course, it was never accessible. So like, we have to fix that. That's a clearly like moral failing, but never mind that. So in any case, any questions, comments, concerns, or was this one straightforward, or do you need more information on some stuff? I do my best to explain, but like at the same time, like I'm human and make mistakes. So. Okay, I'm still not hearing any gnashing of teeth. So I propose a 5-minute break. And then after that 5-minute break, don't forget, you should be looking for a data set that you are interested in, you personally are interested in, so that you can try to run some data analysis by Thursday. And then try to figure out, once you found it, what you'll need to do to like clean it and filter it, or like what do you think you'll need to do with it. But the next thing that we're going to talk about is called loading tidy data frames. Tidy data frames. And the illustrious William Ali, who might be, I'm not sure if he's in there right now, but will be running that one. So, all right, so 5-minute break, and I'll see you all back in just a few as I blow my nose for the 1000th time this week.